Hello, Algebra students. Today we are going to look at scatter plots and trend lines. Your objective is to write an equation of a trend line and a line of best fit, and to use the trend line and line of best fit to make predictions. Alright, so we're not going to necessarily look at the getting ready, so we're going to move on down to our essential understanding. It says you can determine whether two sets of numerical data are related by graphing them as ordered pairs. If the two sets of data are related, you may be able to use a line to estimate or predict values. So the first one is called a scatter plot. So a scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. Most scatter plots are in the first quadrant of the coordinate plane because the data are usually positive and negative numbers. So we are going to need some graph paper. Alright, so you can use scatter plots to find trends and data. The scatter plot below shows the three types of relationships that two sets of data may have. Alright, so hopefully you can tell that this is what we call a positive correlation because all the dots are going up in that positive direction. So when y tends to increase as x increases, the two sets of data have a positive correlation. So once again, y increases, x increases. So this one, y decreases as x increases, so that gives me that negative correlation, and then hopefully you can see it's going down. And in this one, you can see the dots are like everywhere. So this is what we call no correlation because you can't see if it's positive or negative. Okay? Alright, so moving on. So making a scatter plot and describing its correlation. So the table shows the altitude of an airplane and the temperature outside of the plane. So as you can see, they've already graphed these data points for us. So hopefully you can see that it has a trend. So most of the dots look like they're going down. So it says make a scatter plot of the data, which they did. What type of relationship does the data scatter plot show? So as you can see, the temperature outside the plane tends to decrease as the altitude of the plane increases. So the data have a negative correlation. Okay, so that's all you had to do. Just tell me what that correlation is. All right, so we are going to look at the got it, and you will need some graph paper. So it says make a scatter plot of the data. So once again, we only need quad 1. So we're only going to, and as you can see, it goes, this is my x's, this is my y. So we don't need to go very high. Alright, so there's my scatter plot. And so this would be 0, of course. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we need to go 11, up to 11. Alright, so I kind of debated of what to do here. So if we go, yeah, let's do 0.5, and then this will be 1.0, 1.5, 2.0, 2.5, 3.0. We probably should have done one go by tenths, but that would be a very large graph. So let's see what we're going to get here. All right, so remember, some of these we're just going to have to guess. So 10 and 2.5 is definitely here. 11 and 2.8, so that's going to be somewhere right there. 9 and 2.3, so somewhere right there. 10 and 2.6, so right there. 13, oh, we need to extend this, right? Okay, so 13 and 3.3. That would be somewhere right there. 5 and 1.3, somewhere right there. 8 and 2.2, and 4 and 1.1. All right, so hopefully you can see that the trend line is going up. So we are going to call this a positive correlation. Because that trend line is going up. So a positive correlation. What type of relationship does the scatter plot show? Positive. It says consider the population of the city and the number of letters and the name of the city. Would you expect a positive correlation, a negative correlation, or no correlation? Well, we already know that it's going to be, oh, this is different. So consider the population of city and the number of letters in the name. Well, what does population have to do with the number of letters in the name? So we're going to say this is probably no correlation. It doesn't even relate to each other. Okay? All right, so moving on. When two sets of data have a positive or a negative correlation, you can use a trend line to show the correlation more clearly. A trend line is a line on a scatter plot drawn near the points that shows a correlation. You can use a trend line to estimate a value between two known data points or to predict the value outside the range of known data values. Interpolation is estimating a value between two known values. Extrapolation is predicting a value outside the range of the known values. All right, so let's look at our next example. All right, so they're using our trend line. So we're going to write an equation of a trend line. Make a scatter plot of the data at the right. What is the approximate weight of a 7-month-old panda? So make a scatter plot and draw a trend line. Estimate the coordinates of the 2 points on the line. So when you draw a trend line, you're going to kind of connect at least 2 points. So as you can see from this trend line, they made the connection between this point here and it looks like this point here. Okay, even though it does kind of go through these 2 points here, it really hits that point there and definitely that point there. So those are the 2 points that they're selecting. All right, so to write that equation, we first have to find the slope. So remember, we're going to reach back into our memory. Slope, y2 minus y1 divided by x2 minus x1. So 37 and 9/10 minus 17 and 1/10 gives me 20 and 8/10. 8 minus 4 gives me 4. So we divide them. So my slope is 5 and 2/10. All right, then you're going to use that point slope formula because we know the slope and we know one of the points. We actually know 2 points, so we're going to substitute that in. So slope is 5 and 2/10. So y minus 17 and 1/10 equals 5 and 2/10 times x minus 4. So distribute 5 and 2/10 times x, 5 and 2/10 times 4. Solve the equation. We're going to add 20 and 8/10 to negative 17 and 1/10. Actually, we're going to do the opposite. We're going to add the 17 and 1/10 to the 20 and 8/10. So that gives me negative 3 and 7/10. So from there, so now that we have the equation, we want to estimate what it is for a 7-month-old panda. So you're going to substitute in that 7 to that equation, and we know that the weight would be 32 and 7/10 pounds. Okay? All right, so now we're going to try it out. So we are going to make a graph. Okay, and we can go on the bottom, we can do our months, and we can go by ones, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's all we need to go to. All right, and then our other scale, what if we do, I don't know, let's do 5s. Let me see if I can get this to focus a little bit better. All right, so let's do 5. So 5, 10, 15, 20, 25. Nah, I'm not liking that. Let's do, I don't know, let's do 4. So 4, 8, 12, 16, 20, 24, 28, 32, 36. I think we don't need to go any higher than that. Okay, so our first age and length of a panda is 1 month, and it weighs 8 pounds. At 2 months, which is here, it weighs 11.75, so that's real close to 12. At 3 months, it's 15.5, so once again, real close to 16. 4 months, 16.7, so once again, close to that 16. 5 months, 20.1. 6 months is 22. 7 months, they don't give us anything. So 8 months would be 26, so kind of in the middle. And 9 months will be close to 29, so we're going to put it right there. Okay, so hopefully you can see positive correlation, right? So we are going to need to put a line between 2 points. So grab that ruler. And so let's pick a point. So we could pick that one. But if you notice, most of my points are above the line. So you want to pick some points that have almost the same amount of points, either above or below it. So it looks like this point here. And I would say that point there. So I would say this one and that one. Okay? And it depends on how you graphed it. You may have 2 different points, but at least you can see there's 1, 2, 3 here and 1, 2, almost 3 there. So those 2 points. All right, so we know that the points we chose are 2 and 11.75. Okay, 2 and 11.75, and the other point we chose is 6 and 22 and 2/10. All right, so we got to find the slope. So 22.2 minus 11.75. So you guys are allowed to use calculators. And then 6 minus 2. So 22.2 minus 11.75 is 10.45. And then, of course, 6 minus 2 is 4. So we're going to divide that by 4. So 10 and 4500ths divided by 4 is 2.6125. Can't see that. So that would be the slope. So now we're going to take one of these points, and let's use this one right here, the 2 and 11.75, and substitute it back into that point slope formula to get the equation. So move it up. Y minus Y1, so 11.75 equals 2.6125 times X minus 2. All right. So we would still have Y equals Y minus 11.75 equals 2.6125x. And if you want to round that to 2.6, it's not going to make that big of a difference, so you could do that. And then 2.6125 times 2 gives me negative 5 and 225 thousandths. All right, so we're going to add so 11 and 75 minus, because we're really subtracting, right? So that gives me Y equals 2.6125x plus 6 6.525 thousandths. All right, so what was the question? It wanted to know 7-month-old, because that was the number we missed, right? So we're going to substitute in 7. So I'm going to move this over, right? So y equals 2.6125 times 7 plus 6.525. So 2.6125 times 7 gives me 18 plus 6.525. And that is 24 pounds, not pounds, length, right? Okay, so does that fit in between the 22 and 2/10 and the 26 and 5/10? Yep, because we could round that to 24 and 8/10 length. Okay, all right, so that is how you find that information. So the next one is just talking about, do you think you can use your model to extrapolate the body length of a 3-year-old? Well, since we're only talking months, we could, right? But that data, that chart would be really big, but we could extend that trend line out and kind of estimate what it is. We can also substitute, so we would have to do 3 times 12, which is 36, substitute 36 in, and we could figure out what that length is. So absolutely. So we would do 12 times 3, which is 36 months, and then you would just substitute that in. So y equals 2.6125 times 36. So that would be what we would use. So if we wanted to know it, so this is 94, so plus 6.525. So that would be approximately, so 106/10 of a length. Okay? All right. So let's move on to this one. All right. So a few vocabulary words. The trend line that shows the relationship between two sets of data most accurately is called a line of best fit. So that's what we kind of just did, a line of best fit. So a graphing calculator computes the equation of a line of best fit using the method called linear regression. So unfortunately, since you guys don't have graphing calculators, we're really not going to look at the line of best fit on a calculator. The thing that you need to understand about a correlation coefficient is that the closer your dots or your scatter plot is to -1 and 1, the better the correlation is. So once we get to that algebra nation video tomorrow, it will explain that correlation coefficient a little bit better. So it says a graphing calculator also gives you the correlation coefficient, the number. So R is a number from -1 to 1 that tells you how closely the equation models the data. So once again, the closer the dots are to the line of best fit, the more correlation that there is to that line of best fit. Okay, so if there's no correlation, you're not going to have a number that's really close to -1 or 1. It's going to be really spread out. So we're not going to look at problem 3 because once again that's the graphing calculator and we won't be able to do that. All right, so we are going to look at 4. So it says identify whether relationships are casual. So in the following situation, there is likely to be a correlation. If so, does the correlation reflect a causal relationship? Explain. So for example, the number of loaves of bread baked and the number of flours used. Well, if we're using flour, the more bread we bake, the more flour we use. So there is a correlation and it is a causal relationship. Okay? So the next one says the number of mailboxes, the number versus the number of firefighters in a city. So there is likely a positive correlation. Of course, as you increase your population, they're going to have to hire more firefighters. But does one affect the other? No, not necessarily. So this will not cause the number of firefighters to increase necessarily. All right, so in the following situation, there is likely to be a correlation. If so, does a correlation reflect a causal relationship? The cost of a family vacation and the size of their house. Well, so usually we could say that people that live in big, expansive mansions can take a family vacation that is a little more expensive, but is that necessarily true? Nope. People could save for years and years to take that once-in-a-lifetime vacation. So we're going to say that there is, but not always. Okay? All right, and then the next one says the time spent exercising and the number of calories burned. Definitely, there is that causal correlation. All right, that is it. So, your lesson is to work on the lesson check. It is attached in Focus, and I will upload the notes as well into Focus, as well into Team. So you will have this in multiple locations. All right. So once you have completed it, attach it. So you can either download this page or you can write it on a sheet of paper and take a copy of it and attach it into Focus. All right. Have a great day.